Okay, this is recording 2 of my chi-square lecture. Now we're at the two-way chi-square, the test of independence. Okay, this is just used when you have 2 variables and you're counting frequency just like with the one. So the idea is, the question you're asking is, does membership in category A depend on membership in category B? So are people in category, are men category A, men versus women, more likely to hold tenure track jobs, category B, tenure track versus non-tenure track? Our statistical hypotheses for the null hypothesis is just that they are independent, that women are just as likely as men to hold tenure track jobs. Just because you're a woman doesn't mean you're more or less likely, and vice versa. Our alternative hypothesis is that, yes, they are dependent. That's why it's called a test of independence, right? So category membership depends on the 2 variables. So membership in one is going to be different according to membership in the other. In our example, men are more likely than women to hold tenure track jobs. Right. So first of all, our expected frequency. So if everything is equal, how would we expect this to look? The way you calculate this is we multiply the cell's row total. So this is the row total by the column total. So for this one, you multiply this by this. But of course, we see we have no values here, right? So going back to our example, okay, we know that there are 1,298 women and 1,476 men. We just calculated that for our first example, right? Now, to figure out the values for how many people were in tenure track versus non-tenure track jobs, I use algebra. So I'm not going to walk you through that if you want to, because they don't give it here. However, you can solve for it using algebra. If you're interested in knowing how I did that, I'm happy to tell you, but if not, just take my word for it that 1,730 people were in tenure track and 10,044 were in non-tenure track jobs. And to find out how many women, we just have to look at these values. So 42.5% of tenure track were women. So we just calculate it here and so forth, right? So this is the answer. There were 735 women and 995 men in tenure track, so forth. So expected frequency. To calculate expected frequency, like I said, we have to multiply the row total. So we're going to start by calculating this. And to figure it out, we have to multiply row total by column total and divide by n. So n was 277, sorry for the messiness, 4, remember 2774. Anyway, I have it all down there. So, oops, let's actually draw it. So here is the calculation for women, men, and tenure track, and so forth. Okay, so this is just showing you the calculations, right? So this is how we calculate expected frequency. So those are just the result of all these calculations. We can see that we expect 809.5 women in tenure track, 920 men. Okay, this is taking into consideration the quantities in each row and column. Okay, so now we get to calculate chi-square to see if these are significantly different. We can see just from here that our observed frequencies, we can see that they might not be like that, but we don't know. We have to calculate how different these values are from these values here, from the observed. How different are the observed from the expected frequency to figure out if they are significant, if there's actually a significant chi-square, which would indicate that they are dependent upon each other. Okay, so here is the equation for chi-square, test of independence. You just take the difference between observed and expected frequency, square it, divide by expected frequency for each cell, okay? For each cell. So each cell, these are cells, all these are cells. So we have to calculate the difference between expected and observed for each cell. Our degrees of freedom is just number of rows. So we have 1, 2 rows, 1, 2 columns, Okay, so 1 times 1 equals 1, right? Pretty simple. So let's walk you through this. So we start here, we have, this is for this cell, is this one, right? 735 minus 809.5 divided by 809.5. Okay, oh, and you have to square these two up here. And it's the same for each one. So then we calculate this cell here, right? This corresponding one is here. Non-tenure track women, right? Okay, you guys can all see where they're coming from, correct? Okay. It's hard to lecture to an imaginary class, but we can do it. So let's watch how this is done. So I'm just continuing the operations to show you all the numbers. You can download this PowerPoint and look at it carefully if you want. Okay. We end up with a chi-square value of 34.24. Okay, this is pretty big. We already know that our chi-square value from a one-way chi-square, the goodness of fit test, we know that for our 11 point whatever it was and degrees of freedom equals 1, p-value is 0.0007. So we know that this one's going to be even smaller, right? We don't even have to look it up, but you could look it up if you wanted to, right? So what does this mean? So here in this table, I show you the observed frequency and the expected frequency. So we can tell that there are fewer women than would be expected under the null hypothesis, okay, that there's a test that they're independent, and more men in tenure track positions. So men were more likely to hold tenure track positions than women were. Chi-square degrees of freedom equal 1 equals 34.24, p less than 0.001. Okay, pretty simple. Oops, I forgot about that one. All right, if you have any questions, shoot me an email and I will do another recording for statistical software.